All right, this section is 1.6, and we're mainly talking about rational equations because you have seen some radical equations previously, but I will review that just in case you have any homework problems over them. But this week's about rationals, and rationals, the root word of rationals is ratio. So you know you're always going to be dealing with what we're about to do. Basically, if you're given fractions, and the x is part of those fractions. And so we're going to learn how to solve these, and really a couple steps, if you will, if you want to write those down. We basically want to make it no longer look like a fraction, because fractions are kind of scary and difficult to solve. But if we can find a way to not make it look so scary, then we'll be fine. So the first thing is determining the domain, or what can x not be. I'm going to show you this next example. It's a little easier. For example, if I look at x minus 2, and I'm going to go ahead and solve this for a second. X is equal to 2. When I do this, this will tell me the value for which x cannot be. Here's why that works. Think about it. If I plug 2 back in for x, 4 divided by, and I plug in 2 for x, 2 minus 2 is 0. Having a 0 in the denominator is not okay. If you put 4 divided by 0 in your calculator, you're going to get an error. And so in order to kind of figure out the domain, basically these functions can do whatever the heck they want except for the value that makes x 0. And so that's going to change. Like here, it's going to be -1, because -1 plus 1 will give me 0. And so we've got to kind of figure out those values, if you will, for each problem. So if I go back up here, and it's only when there's an x in the denominator that I have to worry about it. So I have an x in the denominator here. So like I did previously, I'm going to set them equal to 0 and solve, which actually these are not so bad because they're pretty much already solved. This one's good to go. We've already got x equals. And then this one, if I divide by 8, 0 divided by 8 is just 0. So what x cannot be equal to is 0. If I plug 0 back in for either this x or 8 times 0, I'm going to get a 0 in the denominator. Again, that's not okay. And so there's a couple different ways you can represent that if you want. I'm going to do a couple different ways. So I know that my x cannot equal 0. But it can do whatever the heck else it wants. So a way to say that is, this looks weird, but x is an element of all real numbers except it can't be 0. That's an easy way to say that. You can write x is all real numbers except it can't equal 0, or your homework will ask you to put it in interval notation. And I'm running out of room. Let's do it up here. And this is interval notation saying the exact same thing that I just said. X can be whatever the heck it wants except 0, because that's the number that makes the denominator 0. Okay, so that's the domain. Now, how do we solve this? We want to get rid of the fraction. And so basically you need to look at this and say to yourself, what do I have in the denominator? Okay. And whatever I have, I'm going to end up multiplying by the whole thing. So I have an x. That's my variable. And I have an 8 and a 16. So when I think of 8 and 16, the least common multiple of these is 16. 8 times 2 is 16. 16 times 1 is 16. If you're a little lost, bear with me. So I'm going to multiply this entire function by 16. It's hard to read that. There we go. And by x. Okay. So when I do that, I have to do it to everybody. So everybody gets a 16 and an x. Every term. I kind of would suggest, not saying my way is the best way, but organizing it in some way that will help you see what you're multiplying. So I usually do it in different colors. So I'm multiplying 16x here, 16x here, 16x here. So then I can kind of see what's going to happen. And what should happen is if you multiply by something that the right thing that's going to cancel these terms out, you won't have a denominator. I'm sorry, you won't have a fraction any longer. So I'm going to, here I notice the x's cancel out. Here I notice the x's cancel out, and 16 divided by 8 will simplify to 2. And then over here the 16's cancel out. Okay. So I look, and 16, now I'm just going to simplify. 16 times 3 is 48. 16 divided by 8 is 2. Oh, that was a plus. X minus 2 equals 13 times x is 13x. So what we've done is we found that number, 16, and the variable x, to multiply across to cancel out. So you need to look at your denominators when you're looking at this, thinking to yourself, what could I multiply this function by that's going to cancel it out? Something that I see happen a lot is the 8 and the 16. People say, oh, I'm going to multiply by 8. That's not going to work. If you multiply by 8, like right here, 8 divided by 16 is 1/2. So you'd still have a fraction. So you're going to multiply by something big enough that it will completely cancel out the denominator. And at this point, it's just a linear function, and it's something that we know how to solve. So I'm going to get rid of the parentheses and start solving for this. And I'm kind of running out of room. But, oh well. And I'm looking at my key, and I did something wrong on my key, so sorry about that. I don't know how to divide, I guess. 48 minus 4 is 44. Move the 2x to the other side. That'll be 11x. Divide by x, and I'll get 4. So x equals 4. Now that is okay. Oops, solution sign. Your homework may do it like this. Those little squiggly lines, that just means the set of. So that's okay. We said x couldn't be 0 and x is 4, so it's all good. If you need to pause this video, go for it. I'm going to move on. Okay. So earlier we had an x and we had a number in the denominator. Oops. This time, something a little different's happening. Looks a little scarier. It's all good. First, if you can factor, if you've got a trinomial or something squared, go ahead and factor it. And so if you need to review the factoring techniques, feel free to go back and look at that video or pause this video to make sure you feel okay about it. I need to make this smaller. So this will factor to be x minus 2x plus 1, which, just so you know, are these as well. And a lot of the times when you're doing these, they'll end up being very similar or the same. So I'm looking at my denominator. So I just made this x squared minus x minus 2 equal to x minus 2x plus 1 because we factored it. So in my denominator, when I'm asking myself, well, let me pause real quick. Looking at those two and then our repeats, we know that x can't be 2 or negative 1. We know that because these are the numbers that make, if I were to plug them in, it would make the denominator 0. 2 minus 2 is 0. Negative 1 plus 1 is 0. So the domain is all real numbers, except we can't be, did I say 2? Yeah, positive 2, sorry, or negative 1. Okay, now we have to figure out what to multiply by. So basically I'm asking you what is in the denominator so I know what I need to cancel out. I've got an x minus 2 and I've got an x plus 1. And as you kind of go through this, you can, and you know you're going to do it right or wrong when you start multiplying it out if the denominator goes away or not. But you can kind of look and say, okay, I've got an x minus 2 here, x minus 2 here. Great, dealt with it. X minus 2, already dealt with it. I've got an x plus 1 and an x plus 1 over here. Okay, so I should, when I multiply this out, everything should cancel out. Again, I'm going to organize this. It's not like my way is the best way, but this is how I do it. But it just takes kind of a long time to write all this out. But I'm hoping that it helps you see what's going to happen here. Okay, so I told myself I'm going to multiply by x minus 2 and x plus 1. And when you do that, you have to do it to every single term in order to keep it balanced. If you don't, then you're not allowed to do that in algebra. So as you notice, everyone got the x minus 2 and x plus 1, and hopefully things should start to cancel. So here the x minus 2's cancel, here they both cancel, and here the x minus 1 cancels. Okay, so you just make sure you stay organized and see what you're left with. So 4 times x plus 1 minus 3x squared equals 2 times x minus 2. Go ahead and distribute that 4 and distribute that 2. 4. So we've got a quadratic. We're going to have to solve this. So normally when we solve, we set it equal to 0. So I'm going to move all these terms to the other side. So you may want to pause the video and make sure that this math checks out on your side and combine all the like terms. It should be minus 8. This is going to require the box method to factor. So if I do, again, you may need to review those techniques. If I multiply a times c, 3 times negative 8, I get negative 24. And factors that add to equal negative 2 are negative 6 and 4. Because of that 3, we've got to do the box method or an equivalent method of your choice if you've got something that works as well. And then I pull out things that they have in common. So x, negative 2, 3x, and 1. So those are my factors, x minus 2 and 3x plus 1. But if I solve, then we're going to get 2 and negative 1/3. Now, here's the problem. My solution set, 2 negative 1/3. If you put this in your homework, it's not going to be right. The reason it's not going to be right is because we said earlier that x couldn't equal 2. But in our answer, we said it was equal to 2. Whenever this happens, it's called an extraneous solution. It just means it's extra, if you want to think of it like that. So, we do not include extraneous solutions in our answer. Like, these are contradicting each other. X can't be 2, but now it is 2. And so all you do is you don't include that answer. So my actual answer is just the 1/3. Okay, I'm going to let you try. I'm not going to erase this just yet. I'm going to let you try this last one. It's a little easier. Just look at that common denominator and try to figure out what you need to multiply by. And you can look on the key to see if you got it right. The last thing, we've already talked about these, and I'm pretty sure your homework only has one question about it, so I'm going to review it. Basically, it's the square root property and how do we get rid of a square root. So Anytime we want to get rid of the square root, we just need to square it. 2x plus 1 equals 25. And solve, let's see, that's be 24. X is equal to 12. Great. But I believe the one on your homework goes into a little bigger than an x squared. I'm sorry, a square root. So I'm going to make one up in a different color. I don't know how this is going to work out, so... Okay, let's say it's the fourth root. So that's the difference between square root and any other root. Square root doesn't have a number, like cubed root, fourth root, they'll have a little number out here. But all it tells you is it's going to help you decide what you need to multiply by, or sorry, to what exponent you need to do this. So like a square root, we square it. When it's to a fourth root, we're going to do it to the power of 4. And just like before, when you fourth a fourth root, you're just going to be left with what's on the inside, and then you just simplify the right side. So 3 to the power of 4 is 81. Again, I don't think this is going to come out as a nice number, but I just made it up. And then from there, the point is you'll be able to solve it like a linear equation. Move the 10 to the other side and divide the 3. So that should be the extent that your homework asks you about these questions. If you have any additional questions, please feel free to reach out. I'll be happy to help.